Good morning, everyone. Myself, Dr. A. Jafar Sadiq, working as a professor in a IIIR department of Sri Muthukumar Institute of Science and Technology. Today, I'm going to cover the topic IoT concepts and applications. This is the open elective. The course code is OCS352. Let us see the syllabus. Unit 1, it consists of Unit 1 to 5. Unit 1 Introduction to IoT. In this unit, we are going to get the evolution of the IoT and what are the enabling technologies that belong to the IoT, and what are the various architectures that has been available in IoT, and what is the simplified version of IoT architecture, and also the IoT stack information also we are going to see. And at the end of this unit, we are going to see about what is fog, what is edge computing, and what is cloud computing. All those paradigms we are going to see one by one. So this is the unit 1, introduction to IoT. Next, we move on to unit 2, IoT components. Basically, we are going to first study about the what are the basic components that is belong to this IoT domain. That's a before going to the components, we are going to study about the functional ecosystem blocks of the IoT systems. And the basic components, it starts with the basic level of sensors. In sensors, we have so many types of sensors. We are going to see one by one. And actuators. Actuators is just opposite of the sensors operation. And smart objects. Smart objects means intelligent objects. And control units. Control units is nothing but in which communication modules they are going to control the external devices. And communication modules like Bluetooth technologies, Zigbee, and Wi-Fi technologies, and global position system GPS, and at last GSM module. All we are going to see in the IoT components of unit 2 in this syllabus. Next, we move on to the unit 3, protocols and technologies. Basically, we need to have a IEEE standard protocols for this IoT structure. It starts with the IPv6 inter protocol version 6, and 6 long range PAN network, and MQTT stands for message queuing telemetry network, and COAP constrained application network protocol, and RFID protocol, and along with that wireless sensors networks and big data analytics. These are the technologies that we are going to study apart from this protocols. Big data technologies, cloud computing technologies, embedded systems, all those things we are going to study in this unit 3. The next unit 4, open platforms as well as its programming. Arduino and Raspberry architecture, we are going to either one of the architecture we are going to study about here. Arduino architecture, and that's programming, how we do the programming using IDE, integrated development environment. So that we are going to study in detail. And GPIO, general purpose input output interfacing pins details, how what are the analog pins are there, and what are the digital pins are there, and what are the pins are input and what are the pins of output. Everything we are going to study about it to interface with the outside world. So these are the gateways to interact with the other devices, with the outside world. It can be either analog value or digital values. So next, signal exchange. So how do we exchange the signals that we are going to send and receive? And cloud connectivity. So we have IoT mainly basically works on the platform of the cloud. So that cloud connectivity also we are going to see in this unit 4. Next, unit 5, IoT applications. So this is what the real time usage of the IoT. So in which are all platforms it is being utilized in the current world. So there's a, it can be in the smart city is one of the application of the IoT, wherein urban planning in the sense, so you right from infrastructure, then sewage, then electrification, then for deforestation, then all those things comes into this smart city. Then mobility and transport is one of the applications. Also depends upon the traffic conditions. So how to make you easy the mobility for the citizens. Next one is industrial IoT. So instead of the human standing in front of the machine and as an operator, he can either use the HMI, human machine interface. So instead of his physical presence, he can be sitting anywhere in the world and he can look after this parameters that is going on in the machine. So that's a very kind of application of industrial IoT. Then smart health systems. Again, smart health systems of the patient monitoring. Then the doctor sitting outside of the hospital, he can be got stuck with the traffic. Then immediately somebody calls and asks his opinion. Means he can easily monitor his health conditions of the patient and he can suggest right away the necessary treatment. So next, environmental monitoring. Yes, environmental monitoring also we can able to do this using a IoT. Then home automation. So nowadays the home automation is predominantly coming up in India also, in major cities as well as in rural areas also. In house planning, they are doing this home automation. And smart agriculture in rural areas is very much important. So farmers, they need some kind of technologies which can make use of them with a less effort, more gain. So that comes under the smart agriculture applications. So these are the 5 units that belongs to this IoT concepts and applications. We will see the first unit in the sessions one by one, starting with the introduction to the IoT. So before going to this, the first unit core objective of this is to apprise the students with the basic knowledge of IoT that paves a platform to understand physical and logical design of IoT. So this is the base knowledge with we have to understand the physical and logical design of IoT to the students. Second point is to teach a student how to analyze requirements of various communication models and protocols for cost-effective design of IoT applications on different IoT platforms. So we have to analyze what is the basic requirement of a particular user and what is his budget, and with this budget we have to make a cost-effective design for that particular customer. So for that we need to know the kind of communication that can use and the protocols that we can be used for reducing the cost. And third one is main objective is to introduce the technologies behind IoT. So what are the technologies are there that we have seen in the unit 3? The same technology has to be applied to make use of this IoT. Next one is to explain the students how to code for an IoT applications using Arduino or Raspberry Pi open platform. Yes, this is the real-time implementation of the theory or the concept that we have learned throughout the unit 1, unit 2, unit 3. We are going to apply those concepts and realize the real-time usage of the IoT. So this, for that we need to know what are the integrated development environment is available for making the code to automate the things. So this we are here only we are making the controller become intelligent. The controller may be Arduino or Raspberry Pi. It depends upon the applications as well as the cost. We can go for either Arduino or Raspberry Pi and we can realize the real use of the IoT. The last one is to apply the concept of IoT in real world scenario. So this is what we have seen the last unit: smart home automation, smart agriculture, smart cities, smart health systems, and like this there are various applications which are going to realize in real-time world. And the course outcome of each unit is unit 1 is going to explain the basic fundamental concept of IoT, wherein the CO second unit CO2 is going to bring out the understanding of the various communication models that are available and also various protocols that are available for IoT. And third one, CO3, is portable IoT using Arduino Raspberry Pi open platform. So we are going to make use of the technologies and communication protocols that are available with respect to the Arduino. Fourth one is CO4, apply data analytics and use cloud offerings related to IoT. So this is where we are going to apply the concepts that we learned through coding or whatever it may be. And finally, CO5 is going to give out the analyzing the particular applications for the particular customers that can make use of the IoT in real-time scenario. Okay. Unit 1 is basically what is IoT? IoT stands for Internet of Things. It's a network of physical objects or things, or whatever you call in double colon things, embedded with electronics, software or sensors and network connectivity that allow these objects to collect and exchange data. Basically, things are going to interact, the devices are going to interact with each other, like human how we interact with each other. Likewise, the physical objects, physical things, we make it as a intelligent object and we make them to interact with the other devices, and hence it realizes the real communication between device to device. That is what IoT, or in other words we can able to explain the IoT stands for Internet of Things. It refers to the interconnected of physical devices such as appliances and vehicles that are embedded with software, sensors and connectivity, which enables these objects to connect and exchange data. Exactly, they are going to connect and after establishing connections they are going to exchange the data. That data is most vital thing in our IoT, because that's most vital part of this IoT, because data exchange is the only thing that we are going to work on it. This technology allows for the collection and sharing of data from a vast network of devices, creating opportunities for more efficient and automated systems. Examples of IoT: a light bulb can be switched on or off from miles away using a mobile device. Is an example of IoT device. So you need not go and physically switch off the bulb and the fan or whatever it may be you call it. You can anywhere in the world can do it using the particular application in the mobile or laptop. Or a motion sensor inside an office combined with a thermostat and a display which provides temperature, ambient lighting and presence inside your conference room at regular intervals is another example of IoT. Say for example, the client meeting is there or board meeting is going on. So temperature is very hot outside. So depends on the temperature, automatically the thermostat which is inside present in the AC, refrigerator or whatever you call it, okay, it has to decrease its temperature so that the cooling may be higher. So if the temperature outside the boardroom or whatever you call, it's very warm as well as not warm, it's very cold, then inside the room you need a modest temperature. So that time the temperature level has to be increased. These things should be done automatically. So this is the another application of IoT. And to start with, we just go through about the how IoT has been evolved from the year right from 1989, wherein the first IoT device is created. Then 1993, the first online webcam is used at Cambridge University. Then 1994, Steve Mann creates a VR cam. In 1999, Kevin Aston calls the term Internet of Things. So first and foremost, the year which we called as IoT as is 1999. Then after a gap of around 9 years, 2008, the number of connected devices overtakes the number of people in the world and IoT is born. So number of, so we have some billions, 7 billions people right from living in the world. So now it in 2008 itself, it crossed over the number of billion people living in the world. And 2009, if you see the original Fitbit activity tracker is released, and going forward after that 11, 14, 15 and 16, 2020, then 2021, there are more than 10 billion active IoT devices available. 2021 see 10 billion active IoT devices available. So, and the last one which I want to emphasize in this history of IoT is in the year 2022, World Economic Forum, so forum available, they have named IoT as one of the most important impactful technological advancement. So this is the whole, this explains about the history of IoT. Then why we need IoT? Because it connects everyday devices for seamless data exchange and automation. Main thing is data exchange as well as the automation only. We need the devices to be connected together and make our life simple. It boosts efficiency by enabling real-time monitoring in industries, like that's what industrial IoT, like energy storage and as well as renewables. IoT drives smarter decisions, cost savings, and scalability for systems like BESS application. Not only BESS, it mainly used for cost savings as well as scalability. Main thing is scalability. What is scalability? Scalability in the sense you can extend the future of the features of the current devices to a new scale, new level, not where there's no restriction for that. That's what scalability means. So this IoT helps in that sense. Components comprising of IoT is there are two major bifurcations when we explain about the components. One is IoT hardware, another one is IoT software. In this IoT hardware, the basic components mainly sensors and the actuators or the routers, we call it as a routers or some gateways. So all those things are the hardware components which are required, and mainly the servers to store all the data. Servers are main the heart of the systems. Okay, and coming to the software side, IoT software, it includes kind of desktop applications like web applications or mobile applications which are responsible for data collection, device integration, real-time analysis and application and as well as processes. So as we have seen IoT components, this is nothing but the gateway, and that's one main component, and analytics part, and things are devices which is the most basic physical part, and cloud Another part, user interface, is also the last part. Sensors and actuators, see sensing devices, example thermostat and a microphone, which interact with the environment and collect the data and convert it into a electric signal. Wherein actuator, which is electric motor, for turning energy into the mechanical level. Next one is gateway. Is communication channel through which devices can communicate and share information to the outside world. And analytics is another component of IoT. Is the data that come from the devices as well as sensors is converted into a readable format or understandable format, and for processing, further processing also. So that's the analytical part, this main component of IoT. Then cloud part. IoT generates a lot of data, and cloud platform allows us to store and process the IoT data received. So cloud means in anywhere can be accessed. So the data can be stored and can be shared, accessed for future purposes. And user interface, this is the last component. IoT provides a visible interface that can be easily accessed and controlled by the user. Some GUI form. See, in mobile app you have a various sub menu or sub app icon will be there. If you press the icon to switch on switch off that particular app, means that's what the interface is, nothing but the user interface. Next we move on to the IoT life cycle. So it starts from the collecting the data, and let's go to the region of communicating the data secure, which is with a secured as well as reliable format. And third part is analysis. As I said, it should be usable, readable by the some other third party applications or whatever it may be. The last one is action, because what all we are doing, finally we need to end up with the proper actions as well as some good results, and the end users has to be satisfied. And some of the applications, just listed out IoT applications. Already we have seen this unit 5, smart city, smart home, self-driving cars, smart farming, and the fitness trackers. The smart factories is also industrial IoT. And hospitality and tourism, even that in that area also it's been widely used. And retail shopping also the IoT has been used. And smart grid, yes, it's very much useful in smart grid. And health monitoring, or patient health monitoring also, it covers the entire thing, right from the smart city, patient monitoring, everything it covers. And these are some of the pictures that depicts the real IoT applications. Again, if you see from the left hand side, smart police stations also need some data to be communicated remotely and controlled remotely. Hospitals also need smart healthcare systems, and the grids also need data to be intelligently exchanged. And banking system also is required. Manufacturing sector also it requires IoT, and smart shipping as well as robotics is very well plays a major role in the IoT. So all this needs cloud data center. So in the cloud is only the center of this picture shows cloud data center, which means servers. Servers is going to store all those data. And another application is IoT in hospitality. It provides innovative benefits to the guest. See, like in a mobile phone, if you have the various controls to make a switch on, switch off the lights as well as the screen curtain movements, and the door lock systems, and alarms, smart alarms also there are there, and smart TVs. Everything can be controlled remotely using in technology called IoT. And in shopping also, this has been widely used, this IoT. So doors, when you go into the doors, scanners are there to identify the tags as well as some clothing, and even the tags also read by the RFID, and automatically bills have been generated. You need not take each and every items and you scan it and do it. If you put it in your bucket, and everything, all the items will be in this one single bucket, means everything will be calculated instantly, and the bills will be generated automatically, and then it send the bills are to your mobile also instantly when you enter the mobile number. So this is what IoT basic thing is. Evolution of IoT means, before, very long before, when the Ethernet device interconnection was there, only within the premises, only within the building only, and the computers are connected together in those days initially. Then later on, when the internet come into picture, all the computers that are being placed anywhere in the world has been make a connection through the concept of IP addresses. That's why then comes into machine to internet. So even with computers, the machines are started doing communications. That's one another. After this, Internet of Things coming to pictures. That means not only machines, smart machines, any devices is embedded with some intelligence can be communicated, exchange data. That is what the Internet of Things. So with this, I conclude this session. Thank you.